Hi, this is Dana with GMAT Ninja, and today I'm going to be talking through GRE word problems for the quant section for the GRE. And who is this video for? It is for you if you panic when you see a wall of text coming at you during that quant section. Very, very common issue. A lot of our students really don't love to see all of those words. So if that's you, you are definitely not alone, and this video might help. This is also for you if you lack confidence in converting all of that text into nice, clean algebra. And also if you waste lots of time deciphering what that question is really asking you to solve in the first place. So today we will cover how to read those word-based questions, how to be really literal as you convert the words into algebra, and then how to choose that easiest way to solve through the question. In terms of difficulty level, we'll start off with some easier warm-up level questions, and then as the video goes on, it'll get a little bit harder, with your last couple of questions being pretty tough. A couple of things to note before we dive into examples. First is don't rush when you're reading the question, because if you misread the question and you are solving for something that you've misread, then you are dead in the water. There is no way that you're going to get it right, even if you're really, really good at math. So you want to take your time when you're reading through the question. Going along with that, answering these questions is not a race to get your pen onto the paper. Instead, what you want to do is read the question carefully, then think through how you're going to actually organize yourself when you answer the question. And then after you've made those decisions, then start writing stuff down. So give yourself lots of time up front before you start jotting stuff down and working through the question. So I will go ahead and pop the first example up on the screen. Take your time, answer that question, and then we will talk it through on the other side. All right, let's go ahead and talk it through. As always, if you need more time, feel free to go back to the previous screen and take as much time as you need to solve through that question. So here we've got two sentences, and the first sentence tells us that 40 people are separated into two groups, one group consisting entirely of Americans and one group consisting entirely of Europeans. From this, we've got a lot of information. First, we've got a total number of people, 40 people. Then we've got the fact that we've got two groups. One is entirely Americans and one is entirely Europeans. So that tells us right away that our number of Americans plus our number of Europeans are going to equal our total of 40 people. Now, before I start writing that as an algebraic equation, I actually want to take the time to really carefully define my variables. For this question, it might seem pretty obvious what your variables should be, but it's really good to get into the habit of making that a part of your process to pause and carefully define those variables. It's definitely going to save you from making a mistake on a more complicated problem. So here, let's just say quite simply that A is going to be our number of Americans, and E is going to be our number of Europeans. So as stated before, we know that our number of Americans, A, plus our number of Europeans, E, is going to equal our total of 40. And like that, we've got our first algebraic equation. Moving on to the next sentence, we see if there are 18 more Europeans than Americans. And right there, you can also see that we've got another equation. And this one is going to compare our Europeans to our Americans. One are going to be on one side and one on the other side. This phrasing does trip people up sometimes. It can be confusing to know, where does this 18 go, right? Is it my A plus 18 or is it my E plus 18? So the way I like to think it through is to think about which one of my two numbers are bigger, right? We know that there are 18 more Europeans than Americans. So we know that our Europeans are bigger than our Americans, right? Number-wise, not size-wise, certainly. So if that's the case, right, we've got more Europeans, then it doesn't make sense to add 18 to that bigger number, right? And then have it equal to our number of Americans. Instead, we have to add 18 to the smaller of the two numbers, and then our two sides will be equivalent, right? So our Europeans, our bigger number, is going to be equal to Americans, our smaller number, plus 18. And what this tells us is that, hey, that number of Europeans, yep, that's 18 more than our number of Americans. And then we've got our actual question here at the end. How many Europeans are there? This is another thing to pause and note down. It is so easy to just go off to the races. I've got two equations, two variables. I know how to solve this. Just going to start going. But what if you solve for the wrong variable, right? There's a chance that at the end, then you correct your mistake. But it is so much better to define really clearly upfront what you're solving for. Here we're solving for our number of Europeans. So I'm making a note to myself of, hey, what is E equal to? Just to make sure I don't make a mistake and solve for A instead of E. All right, now that I've got my variables defined, I've got my equations written, I know exactly which variable I'm solving for. Now we've got a couple of decisions on how to actually go through this algebra. Now, I want to end up with E, so I kind of want to get rid of my A's. There are a couple of different options for that. I could use substitution or I could use elimination. Here, I don't think that there's necessarily one totally right and one totally wrong path. They're both going to be pretty simple and straightforward. But I think that the easiest possible thing to do to get rid of my A variable is to just put A on its own on one side for both of these. And then I can set the other two sides equal to one another, and my A's will magically disappear, and I'm already solving for the thing that I want to solve for. So for this top equation, I'm just going to go ahead and subtract the E so that it ends on the other side. So we get A is equal to 40 minus E. And then for this equation, I'm just going to subtract the 18 and get it to the other side. So we get E minus 18 is equal to A. Now that I've got A on its own on one side of the equations, I can set my other sides equal to one another. So I've got 40 minus E is equal to E minus 18. I will go ahead and get my like terms on one side, so I'll add an E to both sides and get 40 is equal to 2E minus 18. And let's go ahead and get that 18 to the other side by adding 18 to both sides. We get 58 is equal to 2 times E, and then simply divide by 2, and we will get 29 is equal to E. And our final answer here is D, 29. So here we've seen lots of different stuff going on, step by step, how to break down that word problem and make your life as easy as possible. First is to carefully define your variables before you dive in. Second is to carefully note down what you're actually solving for before you get too embroiled in your individual steps. Third is to just directly translate your information from your STEM into algebra as directly as possible, sentence by sentence. Fourth is to choose how to solve through, right? Lots of options of how to do this algebra. I think that this is the easiest possible way. So for this particular question, decided to get rid of those A's and work directly with my E's. And then finally, as you go through, you are being slow, you're careful, you're deliberate, and make sure you don't make a silly mistake as you go through and then lose out on those points. So keep those kind of same steps and same priorities in mind, and I'll pop another question on the screen and we will talk about it after. All right, let's talk it through. So we've got a quantitative comparison question. As always with these questions, let's go ahead and start with what we're given before we get to our comparison. Get as much information as we can, make it as clear as possible, and then we will go ahead into the actual comparison portion of that question. So we are told that each of the cars in a parking lot is white, black, or silver, and that in that lot there's at least one car of each color. Now, let's think about how to translate that into algebra. First, we want to define our variables. So let's just say that W is equal to our number of white cars, and B is equal to our number of black cars. Now, a lot of people might put S as your number of silver cars. For me, because I do not have good handwriting, that S oftentimes starts to look like a 5. So to be extra careful, I'm just going to define that as X and just know that X is my number of silver, because sometimes that does lead to issues later if I think that that is a 5 instead of this nice variable that I've defined. So do what you have to do to make sure that you don't make that mistake. If you've got really beautiful handwriting, then maybe you don't have this issue. So now that we've defined our variables, how can we set this up into an equation? Well, we know that our number of white cars plus our number of black cars plus our number of silver cars is going to be equal to our total number of cars. And we know that there is at least one of each color of car. So all that tells us is that these cannot be 0. They have to be some sort of positive integer number for this equation to make sense. We are then told that there are 3 times as many white cars as black cars, which gives us a nice comparison, a nice equation that we can write with these white and black cars. This is a nice spot to slow down and be careful. Where do I put that 3 in my equation? And just like the previous question, where I know that one of these is bigger than the other, I think that can really help. So if I've got 3 times as many white cars as black cars, then I know I've got more white cars than black cars, right? White is my bigger number here. So I am going to have to do something to that black to make it big, like that white number, right? So I've got my white, and then that's going to be equal to 3 times my black number of cars. So the B goes here. 3 black is equal to white. This has a lot of variables still involved, and then this gives us a way to get rid of one of those variables. So I think it's worth it to go ahead and simplify this by substituting in a variable and just making it a little bit simpler than it is right now. Now, I could go ahead and move this 3 over, have 1/3 W is equal to B, and then substitute that in, but then you're dealing with fractions, and I don't really love that. So instead, I'm just going to take this 3b and substitute it into my original equation and get 3b plus x is equal to my total number of cars, or otherwise known 4b plus x is equal to my total number of cars. And that's pretty much all we can do with the stem itself. Not really much else, nowhere else we can really go with that information. So let's get into the comparison. Quantity A is the fraction of the cars in the lot that are white. So what we're looking at there is the number of white cars divided by the total number of cars in the lot. And we've already done some nice work to get that total number, so let's just write that here. And when we're deciding to rate how many white cars there are, we've got a couple options. We could put W or we could put this 3B because we know that those things are equivalent. And because we've got B and X in the bottom, I would choose to put B in the top because then we know, right, that we've minimized our number of variables in this expression. So we've got 3B, our number of white cars, divided by our total number of cars in the lot. This we are trying to compare to the number 3/4. And algebraically, there's really not much more I can do here. There isn't a great way to split this up or to get rid of any of my variables. So I'm just going to take a step back and look at this logically and see what's going on. One thing that is standing out to me are these numbers 3 and 4, right? So I do have 3b on top and 4b on bottom. If it was just that, right, just 3b over 4b, then my fraction would be 3/4. Right? Because whatever b is, I've got 3 of them on top and 4 of them on the bottom. So those would cancel out and I'd be left with 3/4. But I don't have just that in this fraction. Instead, I've got this additional x that is added into the denominator. And we know that x can't be 0 because there's at least one of each color. So x is going to be 1 or 2 or 3 or a million, right? We don't quite know. But we definitely know that is going to be greater than 0. So what that tells us then is that we've got this fraction and then we are adding stuff to the denominator of that fraction. If it was going to be 3/4, what happens when you make the denominator bigger? Well, your overall number gets smaller. So you can see that with just a simple example, something like if I had 3/4 and then I just made my denominator a bit bigger and made it 3/5, then this is going to be the smaller number out of the two because my top has stayed exactly the same and my bottom has gotten bigger. So because we've got this exact situation, right, where this would be 3/4, but then I'm adding stuff into my denominator, I know for a fact that a is smaller than 3/4. There's just no other way that this could possibly work out. And because this is always going to be smaller than 3/4, then quantity b is the greater quantity, and that is my final answer, b. So a couple of things here, right? Some repetition from last time with being really careful with defining your variables, being really careful with extracting that information from the stem. The one additional thing here is that sometimes algebra gets you most of the way there, and the algebra is very important and super, super helpful, but it doesn't actually get you 100% of the way through the question. When you hit a roadblock like this, where there's not really much you can do algebraically, then what you want to do is just take a step back and think through the logic, right? Is there a way to logically think through what you've got there? Is it giving you more information than it might seem on surface level? So that is that question. I'll go ahead and pop the next one up, take your time and solve it through, and we will talk it through after. All right, let's talk it through. So immediately this question pops up on the screen and we've got this table. And this table gives us some expressions for how to calculate distance from London. Now, a lot of students see the word distance and they immediately start to think of rates and d equals rt, which is often case going to be relevant when you see the word distance, but not always, right? So let's first give ourselves a chance to dig into this question, see where we can get with the setup, and then go from there. So in the text, we learn that Mira left London at 9 a.m. and Imani started traveling toward London at 9 a.m. Now, I don't really want to go crazy with diagramming this, but I think it might be helpful just to sort of get a sense of what's going on here. So let's say we've got London, and we know that Mira left at 9 a.m., so Mira is going out in some direction, and Imani is starting somewhere else and coming toward London in some direction. And of course, we don't know exactly what directions those are, but that makes sense, right? As time increases, Mira is getting farther and farther away from London. Whereas as time increases, then Imani is getting closer and closer to London. So Their distances from London, T hours after their respective departures, are given in this table above. At what time is Mira twice as far from London as Imani? So we've got a couple of things going on here, right? Um, we want to deal with distance, right? So we've got one of these ladies being twice as far from London as the other. Let's go ahead and put that on the page just to see what we're working with. So we've got Mira is twice as far as Imani, right? So that says our distance of Mira is twice as far as the distance of Imani. And then we know that we are solving for some kind of time. And luckily, we already are given a bunch of information about what this distance of Mira is and what this distance of Imani is. It is controlled by this relationship here in the table. So we can just go ahead and plug it in. Our distance of Mira is just going to be 8t plus 176. And then we've got to be really careful here. We're putting in brackets this distance of Imani, 115 minus 2t. And sure enough, now we've got one equation, one variable. Should be fairly simple to solve. Now, to plot forward and see where this is going to get us, though, let's just take a second to think about this variable t. T is t hours after their respective departures, and we know that those departures are at 9 a.m. So we're solving for time, right? I think it's important to note that it's time after 9 a.m. because this is going to pop out some value, some number, but that's not the end of the road. I then need to think about like, okay, cool, that's how many hours it's been since 9 a.m. Now, what time is it now? If that many hours have passed. So somehow just want to note on my page that, hey, I need to make sure I do that final step after I've solved for this variable t. Now let's dive in and do that actual solving. To do this algebra, I could start by distributing out this 2, but that will make these numbers bigger, which I don't really love. And instead, I see that I can just divide out the 2 from both sides of my equation and make my sides smaller, which is nice. So let's go ahead and divide out that 2. We are left with 4t plus 88 is equal to 115 minus 2t. Now let's combine like terms and add this 2t to the side. So we'll get 6t plus 88 is equal to 115. And we'll go ahead and subtract our 88. We are left with 6t is equal to 27. And from there, we can just go ahead and divide both sides by 6. When we do that division, we see that t is equal to 4.5 hours. And again, that's 4.5 hours after 9 a.m. So we've got 9, 10, 11, 12, 1 p.m., and then half hour, so 1:30 p.m. And that is answer choice C on the question, and that is our final answer. So turns out we didn't actually need to use d equals rt at all. This was not a scary rates question. This was simply a word question just like any other, just happened to use that word distance. Let's go ahead and pop the next question on the screen, and then we'll chat about it after. All right, so let's go ahead and work through this question. When my students see questions like this, there are a couple of things that bother them about this particular kind of word problem. And the first of those things is that your answer choices all have tons of variables in them, which can just be a little bit disconcerting, right? We're used to seeing just a number over there. You do a bunch of math, you come up with a number, and then you can see that that number is one of your options, one of your answer choices. And here we're going to do a bunch of math. We're going to come up with something, and then it will hopefully be one of these options, but it just feels a little bit less certain than having that number in there. But in reality, it's the exact same principle, right? All we're doing is starting with the information in text, translating it into algebra, and then at that point, it's just that we don't have to do that final arithmetic step and get to an answer that's a number. We just leave it in its algebraic form. The other thing that bothers people about questions like this is just the sheer number of variables that we're working with, right? So in the question itself, we've already got three variables, right? We've got R reams, we've got S sheets, and we've got T sheets as well. So that's just a lot to keep track of. So right off the bat, all we have to think about that is that we've got to be organized, right? So that's going to be a big part of this question is just staying organized as you work through all this information. So with that in mind, let's start at the beginning and start on our translation. We have a company ordered R reams of printer paper, each containing 500 sheets of paper. Now, just thinking about this, I've got R reams of paper. Don't know exactly how many that is. Each of those reams has 500 sheets of paper. So what I know is that if I take that R and multiply it by 500, then I'm going to end up with my total sheets of paper, right? If I had 10 reams, I'd multiply that 10 by 500, and that would give me my total stock of paper that I'm dealing with. Of course, I don't have 10 reams, I have R reams, but the principle is exactly the same. So I'm just going to write that out as my total number of sheets is equal to 500 R. Looking at the second sentence, we have after each of the printers in the company's office was filled with S sheets of paper, there were T sheets left over. And what this gives me is another way of getting to my total number of sheets, right? Because I've got some number of printers, and then in each of those printers, I've got some number of sheets, right? So if I multiply those two numbers, then I'm going to get the total number of sheets that are actually in the printers. But that doesn't account for everything. There are T sheets left over. So then I have to also account for that. So I'm just going to set it up in the exact same way where my total number of sheets is going to be equal to something. Now, we've got this other thing that's involved here, right? Each of the printers in the company's office. And to make this algebra super, super clean, what I think is best here is to define another variable so that we can talk about that number of printers, and just going to make it as easy as possible and say that P is going to be my number of printers. So my total number of sheets is going to be however many printers I have times S sheets per printer, right? So let's say we had, 10 printers. Well, it would be 10 times the amount of sheets that are going into each printer. But we don't have 10, we have P. So it's just P times S. And this is my amount of paper that's actually in a printer. But then there are T sheets left over. So in addition to this stock, I also have T sheets left over. So just plus T can account for that. Final thing to note here is the actual question, which is which of the following represents the number of printers in the office? And luckily, we already have a nice variable defined for number of printers. So in terms of where we're going, all we're going to do is solve for P. Looking at these, the easiest way to combine them is that I've got total number of sheets on one side of each equation. So let's just go ahead and set these equations equal to one another. So I've got 500R is equal to P times S plus T. And now I'm just going to, step at a time, start solving for P. So first step in that direction, I am going to go ahead and subtract out T. So I've got 500R minus T is equal to P times S. And then final step is I'm just going to divide by S on both sides. These ones cancel out nicely. And I'm left with P is equal to 500R minus T divided by S. Now I'm going to look at my answer choices, and sure enough, it actually matches answer choice A. It's definitely good to be slow, be careful, to be deliberate as you make this comparison. It's very easy to make a mistake at the very end there because these look really similar to one another. But this matches exactly what I've got, so there's no need to overthink it more than that. All right, I hope that was helpful. I'll go ahead and pop the next question on the screen, and then we will go over it after a couple minutes. All right, welcome back. Let's go ahead and work through this problem. So what we have here is a quantitative comparison question. So like always, we'll start with our stem of the question itself, and then we will move into our comparison. In the stem, we are told that a store sells one type of bicycle. In January, the store sold 120 bicycles at some price, and then the store discounted that price for February and sold 200 bicycles during February. The store's revenue was the same in both January and February. So, out of all of that stuff, the place that I'm going to actually start in order to get really organized here is at the end, where we learn that the revenue was the same in both January and February. When you see this verbiage, the same, then algebraically, what that means is equal, right? These two things are the same, they're equivalent. I can set one equal to another. And here I know that the revenues are the same. So I've got the revenue for January is equal to the revenue for February. Now, what's revenue? Well, it's just the number of things that you're selling times the price that you're selling those things at. So I know that the number that is sold in January times the price in January is equal to the number in February times the price in February. And luckily, we are given even more information. We can start getting rid of some of these variables. So we know that 120 were sold in January, so that gives us our number for January. So we get 120 times the price in January. And then we know that 200 were sold in February, so we can say that that is equal to 200 times the price in February. Now we've got a nice equation that's got price in January on one side, price in February on the other side. So we're in good shape to start comparing what we're going to need to compare. But let's make our life even easier. Let's simplify this into its most basic form so that we don't have to deal with big numbers as we get further into the question. First thing I'm going to do is divide both sides by 10. So I will end up with 12 times the price in January is equal to 20 times the price in February. And then looking ahead, I can see that I'm just going to be dealing with this price in January, right? And I'm going to have to do some fancy stuff with the price in February. We've got these numbers 12 and 20. I just vaguely prefer to have the bigger number on bottom. So I'm going to go ahead and solve for my price in February and have the fraction associated with my price in January. Now you could do it the other way. There's no, real wrong answer here. But to me, it just, doesn't hurt my brain as much to just say that I've got 12 over 20 times the price of January is equal to my price of February. And then I can go ahead and simplify this fraction even more. Looks like I've got a multiple of 4 on top and bottom. So this will be 3, and this will be 5 when I go ahead and divide out that 4. So overall, I am left with 3/5 the price in January is equal to my price in February. That's as simple as I can really make it, so let's go ahead and work into our comparison. A is the price of the bicycle in January. I think it's easy just to keep that straight up as my price in January is what I've got on my one side of my comparison. And then here we've got 1.6 times the price of the bicycle in February. So simple conversion in translation there is just 1.6 times my price in February. Now I've got price in January on this side. I'd really like this also to be in that same language in of January. So I'll just go ahead and replace price in February with what I already discovered, which is 3/5 price in January. So now I've got 1.6 times 3/5 price in January. You could go ahead and work with your calculator if you really wanted to here. I think it's easier to work with fractions. So I'm just going to go ahead and convert this into a fraction and then work out and see exactly what I've got here that I'm multiplying my price in January by. 1.6 you can write as 16/10, and that's going to be times 3/5 price in January. And we can just go ahead and let's simplify this while we're at it. Let's divide out a 2. So we get 8/5. And now my arithmetic is quite easy. I've got 8 times 3 on top, so 24, and 5 times 5 on bottom, 25. So I've got 24/25 times the price in January. And that right there is why it's important to check your work. I just had written that variable incorrectly, but just by checking, now I know I've got it right. So what we have here as our final comparison of these two values is the price in January, and we are comparing that to 24 out of 25 times the price in January. This number is, of course, less than 1. So I'm taking whatever the value is for my price in January, and then I'm multiplying it by something that's less than 1. What's that going to do to my overall value? It's going to make it smaller. So I don't know exactly what the price in January is, but I know that this value is always going to be smaller than just 1 times the price in January. So because B is always going to be smaller, my final answer to the question is A. A is going to be the larger quantity. All right, let's go ahead and pop up another example. Take your time as always working through it, and we will talk through it on the other side. All right, let's go ahead and go through it. So this is a lot of text, right? This is a lot to take in. So all you want to do is really make sure that you've got your organizational strategy figured out before you start writing a whole bunch of stuff down. So let's go ahead and read through the whole prompt and decide on that organization. We learned that a machine in a factory fills boxes with oranges, and on a certain day it malfunctioned and filled 1/8 of the boxes with 20 oranges per box, only 80% of the amount required. Okay, so these 20 oranges are 80% of the amount required. If the remaining 420 boxes filled that day were filled with the correct number of oranges, how many oranges were placed into boxes? All right, so we're looking for some total number of oranges here. And within that, we have two categories. We've got boxes that were filled correctly, and then we've got these malfunction boxes that were not filled correctly. So, in terms of that big picture organization, where I'm going to go with this problem is say my number of oranges in the unfilled boxes plus my number of oranges in the totally filled boxes is going to be my total, right? And that is what my question is asking me for. So I need to figure out how many oranges were in the not quite filled boxes and then how many were in those filled boxes, add those two things together, and bam, there's our answer. So the number of oranges in this group of boxes is going to be how many oranges you've got per box times the number of boxes that you're filling. So let's break that down. Which one of those two things is easier to solve for first? I think that the number of boxes themselves are easiest because we've got this nice clean number to deal with, this 420 boxes. We're told that this 420 boxes are the remaining boxes. So what happened previously in the question that can tell us what that means algebraically? Well, we know that 1/8 of the boxes were already filled. And that means that this 420 is the remaining, the other boxes that have not yet been filled. So if 1/8 have already been filled, then that leaves 7/8 that have not yet been filled, right? So this 420 is those 7/8 of the remaining boxes. So I'm just going to simply translate that as directly as possible into algebra. 420 is equal to 7/8 of or times my total boxes, right? And I'm just going to call that B sub t. Total boxes, super clear what that variable means. Let me write that cleaner. Handwriting, also key. So we know that 420 is 7/8 of our total boxes. Let's go ahead and solve for our total boxes. We'll just go ahead and multiply both sides by 8/7. Now you could go ahead and whip out your calculator here, but punching in the buttons on the calculator is in itself a chance to make a mistake, so you don't necessarily want to go for that first off. What I'm noticing here is that there is a chance to simplify the fraction, so let's just go ahead and do that. I know that 420 is the same thing as 42 times 10, and I know that 7 goes into 42 really nicely. It goes in 6 times. So what I'm left with is I can go ahead and cancel my 7, cancel with this 42, and I'm left with 6. So I've got that my total boxes is equal to 8 times 6 times 10. And when I do this math, we get 48 times 10. We have 480 total boxes. So 420 were the ones that were correctly filled. 480 are my total boxes. So how many are these 1/8, right? The ones that were the malfunctioned, ones that didn't quite get filled. Well, it's just going to be the difference between these two. So we've got just 480 minus 420, 60 boxes that were not quite filled to the top. And we're already told exactly how many oranges are filled into those boxes. This accounts for our number in these malfunction unfilled boxes, right? So we've got 60 of those boxes, and then in each of those boxes, we've got 20 oranges. So now I've dealt with my number of oranges in the unfilled boxes. Let's go ahead and talk about this number in the filled boxes. Again, we've got our number of boxes here, 420, but I don't know how many oranges went in each of those 420 boxes. And that's where this last piece of information comes into it, where that this 20 oranges is 80% of the amount required. So this gives us another opportunity to write a simple algebraic translation, right? Where my 20 is equal to 80% of the total required, right? So let's just say that 20 is equal to 80% You can get a little bit more detail on this in our percents video, but I think it's so much easier to work with fractions than with percents or with decimals. So this 80% you can go ahead and translate to 4/5. And it's 4/5 of something, so 4/5 times something, and it's times the amount required, right? So that like, what does a full box look like? That is, it's 4/5 of that. So let's just call that R for required. From here, we can just go ahead and solve for R. So R is going to be equal to 5/4 times 20. And again, we can cancel out some stuff here. We are left with 5. So it will be 5 times 5, which is 25. So the number of oranges that should go in each box is 25. And that all tracks here, right? So 20 was a little bit less than we needed. In fact, it should have been 25. And that's what these 420 boxes got filled with. So now we've got 420 times 25. So overall, combining these two things, we've got 60 times 20 plus 420 times 25, and that's going to equal our total. 60 times 20, the math here is pretty easy, so I'm just going to do it by hand. We have 1200. 420 times 25, that's maybe where I would kind of draw the line, where I might decide to whip out that calculator instead of hand jamming it. I just think I'm less likely to make a mistake on a calculator here. That level is going to be different for everyone, but the main thing is not to be too tied to the calculator. Everything else here I think is easier by hand. But for this particular calculation, I would go ahead and whip out a calculator and figure out that it is 10,500. And then when we add these two things up, we will be left with 11,700 total oranges. And that matches with answer choice D, which is our final answer. So a couple of key points on this question. First, and I think most importantly, is starting with the big picture. How are you going to organize yourself, right? The order in which you do the other things might not matter as much. Maybe you did some stuff first. Maybe you figured out the number of oranges per box earlier than I did. Totally, totally fine. But the main thing is to know why you're doing what you're doing, right? Give yourself that overall framework first, and then start picking out the details that are going to help you fill in the blanks that you need. So that's number one. And then number two is just, this is a lot of steps. So be careful, check your work as you go. Use things like fractions so that you're not dealing with gross decimals. Don't whip out the calculator too early because it can actually just lead to errors with punching in the numbers. But then, if you do find something where you think, man, this is just easier with a calculator, go ahead and use the calculator. All right, let's go ahead and go through another question and we'll talk about it after. All right, let's talk it through. So couple of things here. First of all, this is a lot of text, right? That's just a lot of information to take in. And second thing is, again, our answer choices are written with all of these variables. This is probably what stops my students cold the most often. They just look at that and are unhappy about this question. But as always, with this complicated question, and you've got some answer choices that look maybe a little bit nasty on first glance, the key to solving this question as easily as possible is to be organized. So what you want to do is to set that organizational strategy up early in the question so that you know that you're choosing that simplest way to put all this information in place. So what we have here is a sadly familiar concept to a lot of us, which is that you've made some plans with friends. You're all going to go to this vacation rental. You're going to split the cost, but then some friends drop out. And in terms of getting this organized, I'm actually going to start here with what this question is really asking us for. We're asked, which of the following represents the additional amount of money that each of the remaining friends will have to pay to cover the cost of the rental? All right, this is interesting. So what happened is that there was an initial cost that everyone was set to pay, but then some people dropped out and our cost per person went up. So what this is asking us is, well, how much did it go up, right? What was the difference between the initial cost that everyone was prepared to pay and then the higher cost that now people have to pay because there are fewer going on the trip? So because we're talking about that gap, that difference between the two, we can set that up as a subtraction, right? We're going to have our higher cost, and then we're going to take out that initial cost that everyone was going to pay anyway, and then we'll be left with just the additional bit on top that people need to pay now. So let's just write that out to be as clear as possible. What we are looking for is our new cost that's higher now that people have dropped out, and then minus our initial cost that everyone was prepared to pay. And that is overall what we are looking for. That is the additional bit on top that now people have to pay. So between these two things, we've got our new cost and our initial cost. The initial cost is going to be the easiest to start with, so let's begin there. We know that there were initially F friends and that the total cost was X dollars. So that X dollars, however much it is, maybe a couple of grand, is going to be split evenly between these F friends. So our initial cost would be X divided by F. Unfortunately, this is not how it worked out. The cost went up. So let's talk about this new cost that people have to pay now that those other friends dropped out. Well, the total amount of money is still going to be the same, right? They're not going to drop the price of the rental just because fewer people are going. So we are still left on the hook to pay for X total dollars. But how many people are going to have to pay for that, right? How many times are we splitting this bill? Well, we had F friends initially, G dropped out, so how many are left going on the trip? It is going to be F minus G friends that are left on the trip. And all we have to do is subtract this fraction from that fraction, and we will end up with what we're looking for. Now, we've got this algebraic expression, right? We could be done here, except for the fact that our answer choices are not in the same format. And specifically, we've got two fractions here, and then suddenly we've only got one fraction in these answer choices. So what we need to do is get this into a format that just looks a little bit more similar to these. And we've got to combine our fractions together. In order to combine fractions, just like you combine any other fraction, what we're looking for is a common denominator between the two. So what I'm going to do is I'm going to multiply this one by this denominator, and this one by this denominator, because then I know that I'll end up with something consistent along the bottom of both pieces of the fraction. So we will multiply this by f over f, and we will multiply this by f minus g over f minus g. Now we can go ahead and combine our fractions because we've got the same denominator on the bottom. So on the top here, we've got f times x, and then that is going to be minus x times f minus g. And the whole thing is over our denominator of f times f minus g. And again, this looks really nice. Now we've got one fraction. Sadly, it is still not in its most simplified form that we see in the answer choices, so we still have to go one step farther. There's no way of simplifying what we have up top as written, so what we can do here is distribute out this x, and then see what we've got, see if that simplifies matters. So that gives us f times x minus x times f, and then be careful here, right? Because we've got this minus that applies to our entire term. So we have to take into account that minus times this minus, we end up with plus g times x. And then all of that is over f times f minus g. Now, these two things are just the same exact term written in two different ways. F times x, same thing as x times f, and I've got one minus the other. So these will just nicely cancel out. And I am left with g times x over f times f minus g. Now take a look here, and that is exactly equivalent to d, and d is our answer. So overall punchlines here, main thing is this, right? This initial organization is going to help so much with determining how you actually move through this question and making sure that you take just that simplest, easiest path forward. All right, and we will do one final question. I will go ahead and throw that on the board here in a second, and we'll chat through at the end. All right, let's go ahead and go through it. So another quantitative comparison question, and again, big wall of text, so let's go ahead and read it through and then decide on that big picture strategy on how to solve through. We've got in a school district, 75 eighth grade classes were asked to record the number of pupils in the class that play a musical instrument. 74 classes correctly recorded the data, but one class made an error. 13 pupils in this class that do play a musical instrument were recorded as one pupil in the data. The average number of pupils per class that play an instrument was recorded as 8.08. So right off the bat, what I'm thinking here is that the key to this question is a relationship that most of us know, which is that the average of a group of numbers is going to equal the sum of those numbers divided by the number of numbers that you're working with. And we've got a couple of different averages going on here, right? This 8.08, that is an incorrect average, right? We've got an error in our data and we're ending up with this incorrect average. Then in our comparison, we're going to be asked to compare a number to the actual average of the number of pupils per class that play a musical instrument. Kind of a mouthful. So this average is going to be then our correct average that we're dealing with. Since we're given so much information about that incorrect average, let's start there. And I'm just going to be super clear with myself and label this entire section as my incorrect numbers that I'm dealing with. And my incorrect numbers are, I've got the average, 8.08, and that is equal to some sum, and then my number of classes is 75. To really carefully define this variable, I'm just going to call it my sum and then I'm going to put a little I down there to make sure I know this is my incorrect sum. So from this, what I can go ahead and do is calculate my incorrect sum, and then I can use that to go in the direction of finding my actual correct information here. So let's go ahead and do that. If I just multiply both sides by 75, then I will get my incorrect sum is equal to 75 times 8.08. This to me is a great time to pull out the calculator. So, good time to pull that up. And if you do that calculation, you will end up with 606 as your incorrect sum. So now moving from my incorrect data into my correct, what it should have been data. Well, what happened to my sum, right? What happened with this incorrect data as compared to what it should have been? Well, it should have been 13 pupils, but it was recorded as one pupil. So we've got 13 pupils who are out there all working hard at their instrument. Maybe it's like guitar or something. And sadly, a lot of them did not get credit for that. Only one pupil was recorded in the data. So what's the difference here? What are we missing? How many students should have been included in our sum that are not? Well, we recorded one when it should have been 13. So one of these people did get credit, but then 12 did not. So for my correct data, what I should do is take my incorrect sum and add in the 12 that did not get credit. And then that will give me my correct sum, which is 618. So 618 pupils actually do play an instrument instead of just the 606 that got recorded. So now that I've got my correct sum, I can work out what my correct average is supposed to be. So let's go ahead and carefully label that as well. My average, and let's say sub C for correct, is equal to 618, my sum, divided by my n. We've still got that same exact number of classes. Again, to me, this is a great time to whip out your calculator. And when you do that calculation, you end up with 8.24. So our actual average number of pupils per class that played a musical instrument is 8.24. That's exactly the same as the number that we are trying to compare to, which gives us a final answer of C. Both of these quantities are equivalent to one another. All right, so that is our final example for the word problems video. I hope this has been helpful for you. We've gone over a couple of key concepts, so just to quickly run through those again. Step one is to read that question really carefully because it's so easy to just mess up on and be answering the wrong question. Step two is to decide on your big picture strategy early on in the question. You've got a ton of information to deal with. How are you going to organize yourself so that you're choosing the easiest path? Step three is to define your variables really carefully. Make it idiot proof so you know exactly what you're dealing with, exactly what you're solving for. Next thing is to translate your words into algebra as directly as possible. You're just looking to, set up some sort of equation or inequality and then plug in information as directly as possible from your words into an equation. And then finally, just like with all quant questions, you want to be really careful as you go through the just algebra steps of your question and check your work as you go. So I hope you have enjoyed this video. Thank you so much for watching, and see you next time. Bye.